Hey, Algebra 1, just wanted to go over the rest of what we weren't able to get to on Wednesday of this week. So we left off with identifying perfect square trinomials. We went over these first two problems that you see here. So let's pick up with this third problem. So to identify a perfect square trinomial, what we really need to look at is this first term a perfect square? And it turns out that it is. The square root of that would be 2c. And then we have to ask ourselves, is this a perfect square? And of course 25 is. Its square root is 5. And then remember what we were doing is we were saying, okay, so if we multiply these two things together, right, 2c times 5, well 2c times 5 is 10c. And then we would need to double that to get 20c, and then that means our middle term is correct as well, okay? So that means that checks out. So what this turns out to be is 2c. This minus sign tells us I'm going to have a minus sign in both of my sets of parentheses, and then the square root of that last term is a 5, okay? And I'm going to have two of those, 2c minus 5. All right, so these are both perfect square trinomials. All right, let's move on to the next slide. Now, so these guys we already said are perfect square trinomials. We checked that out. So what I wanted to do is give you a few that are not perfect square trinomials and see if you can figure out why. So if you'd like to pause the video for just a minute, go through all three of these trinomials and see if you can figure out why they are not perfect square trinomials. Okay, hopefully you had the opportunity to do that. This one is not, because 12 is not a perfect square. R squared is a perfect square. Its square root is r, but I don't have a whole number perfect square of 12. 12 does have a square, I'm sorry, I do not have a whole number square root of 12. That's what I should have said. So 12, of course, does have a square root, but it's not a whole number. So that means that's not going to work for us. We can't say that that's a perfect square. So this one's going to be a no, it is not. This one, square root is p. Now this one's a little tricky because the square root of 36 is 6, but here's the thing. We have to have a plus sign in front of our square root, because what we are in front of our perfect square here, our perfect square constant at the end, what we would need to take a look at is this symbol right here. If we didn't catch this piece of it, we would say, well, this works out to be p minus 6 times p minus 6. But think about this. What happens when I take negative 6 times negative 6? Negative 6 times a negative is positive. Right? So this should be a positive 36. So the reason that this one is not a perfect square trinomial is because of this negative in front of the constant. That messes us up. Okay? And this last one, why is this one not a perfect square trinomial? The constant is a perfect square. The c squared component of the leading term is a perfect square, but the 3 is not. Okay? So again, we can take the square root of 3, but it's not a perfect square, meaning that we end up with a whole number square root. All right? Okay, moving on. All right. So basically, here's what's going on. When we first started this whole section of the lesson, we started off with something that looked like this. I think I actually wrote it out as d plus 7 times d plus 7, but of course I could rewrite that. The whole definition of an exponent is when we're using that to represent a base being used multiple times, you know, to multiply those together. And so this is the other representation of d plus 7 times d plus 7. We can call it d plus 7 squared. And we've already figured out earlier I think this was on Wednesday when we talked about this, we figured out that d plus 7 squared is equal to d squared plus 14d plus 49. So it makes sense then that we could go the other direction. And we could say that d squared plus 14d plus 49 equals d plus 7 squared. All I did was write this initial statement that we already know to be true. I just flipped it on either side of the equal sign and wrote it backwards, which is totally okay, right? Okay, so this one we figured out, r minus 5 quantity squared works out to be this particular trinomial. So it makes sense then that this particular trinomial is going to break down or factor into r minus 5 quantity squared. Same thing with this last one here. You guys can take a look at that. So basically this is the rule that we're going to follow, okay? And I'm going to show you exactly how to apply this on the next screen. So when we have a perfect square trinomial, this is the format that it's going to be in. You're going to have an a squared term at the beginning, a b squared term at the end. That's why these guys have to be perfect squares. And then a plus 2ab in the middle. When this sign, the sign in front of the middle term is positive, that means the sign in front of your, or in your parentheses is going to be a plus sign. Okay, that's how we know. So, the way that we're going to get this is you're just going to, once you find out that you've got the proper pattern going on here, you're really just going to take the square root of the first term and put it here, the square root of the last term and write that here, and then of course you double check that middle term to make sure that that is double the product of those square roots, and then you write it in this format with a little squared hanging up in the air. So here's the other, this is the only thing that's different about this second version is I've got a minus sign in front of my middle term, and when that happens I'm going to have a minus sign in my parentheses when I break it down. Okay, so let's take a look at this in action. All right, so let's double check. Let's make sure that we have perfect square trinomials, which means we are going to have a pattern of a squared plus or minus 2ab plus b squared. Okay, so be careful of this. All I'm saying is that this could be a plus and it could be a minus. In a perfect square trinomial, this one, all the sign in front of your last term always has to be a plus sign. Okay, all right, here we go. So is this a perfect square? Yes, its square root is j. Is this one a perfect square? Yes, its square root is 10. What happens when I multiply these guys together? I get 10j. When I double that, I get 20j. So it's pretty much looking like I have a perfect square trinomial here. So here's the way you factor this thing. You're just going to say, what's the square root of my first term? Well, we already figured that out. It's j. What's the square root of my last term? It's 10. What's the sign in front of the middle term? It's a minus. And that thing has to be squared. And that's all that there is to it. This is actually, once you pick up on the pattern, this is a super, super, super easy thing to do. It's a very easy thing to factor. So let's do this next one. Okay, number 2. Is m squared a perfect square? Yes. What is its square root? M. Is 49 a perfect square? Yes. What is its square root? 7. We should also be checking to make sure that this last term is a plus sign, and we're good to go there. So this one was good. I like the check mark better there. Let's do a check mark. This one was good. Okay, now let's multiply these guys together. M times 7 is 7m. Double that, I get 14m. All right, so let's set up, I know now I have a perfect square trinomial. Let's set up our structure for our factoring. Square root of the first term is m. Square root of the last term is 7. I've got a minus sign in front of the middle term, so this one's a minus, and I'm finished. That's all that there is to it. Okay, all right, let's do this again. Is 4h squared a perfect square? Yes. What is its square root? 2h. Is 9 a perfect square? Yes. What is its square root? 3. Do I have a plus sign in front of the last term? Yes. So far so good. Let's multiply these guys together. 2h times 3 is 6h. And now let's double that. We get 12h. We know we have a perfect square trinomial, so we know that we can use this pattern to factor it. It's just going to be my first square root, my last square root, the sign in front of my middle term, and I am finished. That's it. Okay? All right, now let's take a look at this one. Is this a perfect square trinomial? Well, the r squared part, the first term, is the first term a perfect square? The r squared is a perfect square, yes, but is 2? It is not. So as it turns out, this thing is not a perfect square trinomial, so we can't use this pattern. Now I could play around with this and look at the different combinations of factors and things like that to see if I can make the middle term match up. But that's kind of a different lesson. So it doesn't mean that this is not factorable. Let me try to do this really quickly and see what would happen here. So I would end up with 2r times r. I could do a 3 here and a 3 here. Both of those would be plus signs because of all the plus signs in the trinomial, but this would be 3r and 6r. That would make 9r altogether, which does not match. So that doesn't work. Notice I don't have any flexibility with my 2r and my r. Keep in mind we're kind of going back to a previous lesson right now. Before I say this thing is prime, I just want to make sure that it's not factorable using some other method. So what I could do is put a 9 right here and a 1 right here. But if I put a 9 here and a 1 here, this is going to give me 18r plus 1 more r is 19r. Well, that's too much, so that's not going to work. The only other option I really have is to switch that 9 and 1 around. Okay, so I could put a 9 here and a 1 here. This would give me 9r. This would give me 2r. Add those together, you get 11r. So as it turns out, I can't factor this thing, right? That's not possible. We did what we needed to do and we double checked all of our possibilities, but we're going to say that this one is prime. Okay, I just don't see a way to factor that. Okay, let's check number 5. Is this one a perfect square trinomial? V most definitely is a perfect square. Its square root is v. 8 is not a perfect square. That's not going to work, okay? So the only other thing I could do with this is try and find factors of 8. I could try and do 2 sets of parentheses, v here, where we find factors of 8 that are going to give me a sum of 12. And it does not look to me like there's going to be anything that works with this one either. So, you know, we could try 8 and 1, but that would give us 9v when we check our middle term. I could try 4 and 2, but that's going to give us 6v when we check the middle term. So it looks to me like this one is also not factorable. So you can either write out the words not factorable, or you can write out prime. Either one is okay. Different textbooks do that differently, and I'm not sure how Accelerate was tackling that. So that being said, let's go ahead and get you to your practice page. These practice problems, I want you guys to factor these if you can. Number 8 is kind of similar to what we did the first practice page that we did on Wednesday, where they want you to factor out GCF first, then factor the perfect square trinomial. Okay, so keep that in mind. Here's what I recommend. I'm going to ask you guys to press pause and go ahead and work out all of these problems, and then when you push play again, we will check your answers on the following slide. So go ahead and press pause now. Okay, all right, so hopefully you had a chance to get those worked out, and let's check your answers. Here you go. Square root of y squared, pardon me, is y. Square root of 36 is 6. When you multiply these together, you get 6y, and double it, you get 12y. Okay, so, and a minus goes in the middle because we have a minus here. Square root of 9t squared is 3t. Square root of 64 is 8. I have a minus here, so a minus goes here. Let's double check our middle terms. I hadn't done that yet. So 8 times 3t is 24t, and then we double that, we get 48t, so it does work out. Okay, 2c is the square root, 5 is the square root. Multiply those two together, you get 10c. Double that, you get 20c. Okay, this is a positive, so that means I've got to have a plus sign in here. Square root of 25g squared is 5g. Square root of 81 is 9. Minus sign here, so I need a minus sign here. Let's double check our middle term real quick. 9 times 5g is 45g. Double that, you get 90g. So we're in good shape. At some point, I know earlier, you guys, I was checking my middle term first to make sure it was a perfect square trinomial, which is probably technically the better way to do it. But I also know that sometimes, especially when you're learning something new, if you write down what you think it's going to be and then you use this structure, to double check that middle term. For some of you, that might be easier. I just want you to recognize that that middle term at some point must be checked. So for instance, if this were a minus 13y, this is no longer a perfect square trinomial. So I would not be able to factor it this way. Okay, so be careful of that. Make sure you're checking that middle term. 49d squared, its square root is 7d. Square root of 25 is 5. Plus sign here, plus sign here. Let's check our middle term. 7d times 5 is 35. Double that, we get 70. Okay, sorry, 35d and 70d technically. All right, now let's take a look at this one. Square root of n squared is n. Square root of 4k squared is 2k. This one is a minus sign, which means I need a minus sign in my parentheses. Let's double check our middle term. 2k times n is 2nk. Now let's double that. We get 4nk, so we are in good shape. Number 7, square root of 25a squared is, whoops, do you see that? I messed that up. I wrote this out right before I started recording this video, and I wrote down the wrong thing. All right, square root of 25a squared is 5a. Square root of 81b squared is 9b. This sign is a minus, which means I have to have a minus in my parentheses. Let's double check my middle term. 9 times 5 is 45, and 45 doubled, or 45 times 2 is 90 AB. Okay, you guys see a problem with this? So what that means is, even though I wrote this out, I went back and checked my double term or my middle term, and it did not work. That means this thing, as far as I know, I could try to play with some other stuff, but I'm guessing at this point that this thing is prime, and I'm not going to dig into that too deeply right now just because I don't want to take up your time. We're already at 17 minutes. So number 8, we have to factor out the 2 first. We end up with 2 times d squared minus 14d plus 49. Square root of d squared is d. Square root of 49 is 7. Minus for the middle term, so a minus in my parentheses. Multiply these guys together, you get 7d. Double it, you get 14d. So we're good to go on this one. Okay, so that's it. If you guys have any questions for me, please feel free to let me know. Thanks so much for watching. Bye-bye.